Hello everyone, these are students from Makerere University Business School, Bachelors of Business Statistics, Year 3, and a class of Production Statistics, and we are going to present Topic 3, which says Quality and Statistical Control. My name is Kunhira Jen, today's moderator. Let my other colleagues introduce themselves to you.
Hello everyone, this is Joy Giresekwat Wani. Thank you.
Hello viewers, I am Elton Isaac Mwanika and I'm glad to share with you.
Hello everyone, I'm Amutire Abeth. I'm happy to be here.
Hello everyone, I am Amayo Mary Magdalene. I am glad to be here.
So as I earlier told you, our topic is topic 3, Quality and Statistical Control. So quality is defined as the ability of a product or service to meet the customer's expectation or the ability to conform to the standards set. So in other words, quality doesn't only mean the product has to be good, but does it satisfy the customer? That's what quality is. I'll give an example of, let's say, a phone. I, as a customer, when I buy this phone, it is supposed to work efficiently, smoothly, faster, or it has to be also durable, rather than the manufacturers who do it at the expense of them getting more profits, putting it expensively, yet it's not functioning well. So under that, we have dimensions of quality. So dimensions of quality, one is performance. Does the product or service do what it's supposed to do? Define tolerance. Here, I will give an example of, let's say, a car. A car is supposed to move on smoothly, efficiently, so it shouldn't be of this type where we have to go to the garage. That's what it means when say performance. And then the second one is durability. For how long will the product last and under what conditions? For example, I'll give a PC that lasts for 5+ years. It has to be durable. Third one is features. Does the product or service possess to the specified features? I would say in an event of the features such as the Face ID on an iPhone, fingerprint on Techno phones. So those make a product more quality and more reliable when you're using such an iPhone or such phone. The fourth one is conformance. Does the product or services conform to the specifications? Let's say for a drug is supposed to be manufactured in line with the set procedures of the medical. So making a drug without following those procedures, it may not be of use and may not be accepted on market. The fifth one is serviceability. Is the product relatively easy to maintain and repair? When you're making a product to us, the consumers, you're supposed to put maybe the spare parts of that very product or a specified technician, other than selling us a product where getting its spare parts will be a very hectic stuff to us. So another one is aesthetics. How does the product look like? I'm going to talk of how the product is designed, how it is packaged. This is supposed to be done in a way it improves the quality of the product. There are some products on market that are poorly packaged. Actually, packaging is always attached to quality. Then we have perceptions. Product or service must possess adequate or even superior dimensions of quality, but may fall victim to public perceptions. We as the consumers must have a good reputation of your brand. I would say an example of Coca-Cola or NTN, Uganda's economy. They have a good reputation. This attracts more customers, and it's not only because it has a good reputation, but even the quality, the products they offer are of good quality. And the last one is reliability. Will the product consistently perform within specifications? The product should perform exactly important as to why the consumer bought it. That is for the dimensions. To sum it all, I would say a product is only termed to be of good quality only if it satisfies the customer. This is for me. Then my other colleague can pick me up from there.
To add on what she said, I'm going to mainly go through further for the history of quality and statistical control in production statistics. I believe in all things there has to be a history of everything. So basically this time around we are going through the history of how quality and statistical control came in about. First of all, we are going to look at the pre-industrial era, that is before the 1900. Production was carried out by skilled craftsmen. Quality depended mainly on individual skill and manual inspection. There were no formal statistical methods. Inspection occurred after production defects. So in this case, we look at mainly what skill do you have? Can you make something better out of something? It was mainly what you have attained, not what you may guess or what you can try. It's all about what you have attained. The next is the scientific management era, which is in the early 1900s. With industrialization and mass production, work processes became standardized. Inspection departments were established in factories, and efficiency became a major focus in production. With the industrialization and mass production, this mainly looks at the fact that your work processes, have they become that standardized? Are these departments being standardized? So that's all about the scientific management. So when we look at the next, which is the birth of statistical quality control in the 1920s to the 1930s, we see that statistical methods were introduced to monitor and control production processes. Control charts were developed to distinguish between common and special causes of variation. This marked the beginning of statistical process control. So when we look at this, it's mainly focusing on how you are going to monitor and control these processes, which processes will later be talked about. So let's go to the next, which is the World War II period, which is in the 1940s. During World War II, quality control became essential for military production. Sampling inspection methods were widely adopted, and statistical quality techniques were taught to engineers and production managers. So when we look at this scenario of the World War II, we see it that it was so essential for this military production in that you need to involve in the sample inspection methods to make sure you widely adopt all the statistical quality techniques. For the next is the post-war quality revolution, which is in the 1950s to the 1970s. After the war, continuous improvement approaches gained importance. Organizations began focusing on company-wide quality control, employee involvement, and systematic process improvement. So we see that however much in the World War II period there was much of essentials for the military production, we see that in this case for the post-war, it's now an upgrading in that there became a continuous improvement approaches being gained. We see that organizations began focusing more on companies in terms of quality. They start finding out what are we missing, what was that thing that we could not figure out or think of in the World War. When we go to the next, which is the total quality management, which is in the 1980s to the 1990s, we see that management expanded beyond manufacturing into service industries. Customer satisfaction, organizational systems, and international quality standards became central themes. We see that in this case, it goes beyond manufacturing into the service industries. It now enters into how is the customer reacting to such. Is he satisfied? Are there some forms, some organizational systems that are being implemented, and perhaps some international quality standards? Have they enriched to that extent of becoming the central themes? The next is the modern era of 2000s to present. So today, quality control integrates advanced statistical techniques, automation, real-time data monitoring, Six Sigma, lean manufacturing, and data analytics to enhance production efficiency and minimize defects. So we see that now we have laid a background. We can relate with what used to be in the past, and now it has brought us to the knowledge of things that quality control not only just looks at what we have seen in the past, but also it has integrated advanced statistical techniques. We are seeing now the involvement of the AI there is some automation in some things. We have now the real-time data monitoring. We don't just assume, we don't just guess around, but now we are applying certain things and they are more faster than before. Basically, the history of quality and statistical control shows a shift from simple inspection of finished goods to proactive data-driven process control systems. Modern production statistics emphasize prevention, continuous improvement, and technological integration. So my colleague will continue from there.
Okay, thank you, Madam Joy. Let's have Amayo Magi taking us through quality measures that are internationally accepted.
We have the quality issues that are internationally accepted. Basically, when they say quality issues that are internationally accepted, they are meaning the problems that are accepted. For example, we have the International Organization for Standardization. Under this, we have product failures and defects. When we say product failures and defects, these are standards set by the International Standard Organization to help reduce errors, wastage, and product failures by establishing important quality and control processes. We also have safety risks. Under safety risks, these are specific standards that address hazards in high-risk sectors, such as International Organization 22,000 for food safety to prevent contamination, and International Standards for Organization 45001 is for occupational health and safety to reduce workplace accidents. We also have market access barriers. For this, it often faces rejection in international markets. Businesses often face rejection in international markets. So, the Uganda National Bureau for Standard Certificates acts as a passport for local products to enter regional and global markets by proving they conform to recognized benchmarks. We have also information security branches, such as International Organization for Standardization 2700 provides a framework for managing digital risks and protecting sensitive data against growing cybersecurity threats. We also have measures put in place in order to have a desired quality control system. Under this, to achieve a desired quality control system, the following should be done. We have quality planning. Under quality planning, an organization should always set standards and be specific. They should always set measurable objectives. When I say measurable objective, basically meaning they should always set objectives that are ready to be attained. We also have quality assurance. Under quality assurance, organizations should develop procedures and documentations. They should train their employees in order for them to achieve these objectives. We also have quality control. Under quality control, these organizations should use inspections and statistical tools. They should also monitor processes with control charts in order to attain the objectives that they have set. We also have standard operating procedures. Under this, the organizations should always write instructions for consistency. When I say consistency, they should always comply with what they want. They should continue doing their objectives in order for them to achieve what their target is. We also have employee training. Organizations should always train their employees in order to improve on their skills and also awareness of quality policies. My colleague will continue from here.
Okay, thank you, Madam Amayo Mary Magdalene. Let's have our fourth presenter going to do audit, and that's Abeth.
Thank you for an opportunity. I'm going to talk about the audits. Audits generally means if everything is done on a correct order according to the rules. For example, we have types of audits. We have internal audits conducted by the organization itself. If I use an example of MTN, MTN have a team of auditors who check and see if airtime dealers don't limit money with time. And if they find it's not done in the correct order, then they report to the MTN bosses to fix it quietly. And we have external auditors. External audits. External audits are conducted by the independent bodies or regulatory authorities. Here, I can give an example of Stanbic Bank. Stanbic Bank hires auditors from outside and they come, they check the accounts, then after they publish them for their clients to check if the numbers correspond. Then we have supplier audits. Supplier audits evaluates the quality system of suppliers. They are used to check if what is ordered is what is delivered. Then we go to the importance of audits. Audits are used to identify the weaknesses in the quality systems, to see if something lacks anything and they fix it. Then they implement the corrective and preventive actions. They ensure the continuous compliance with quality standards. Audits helps companies or employees to do everything on the standard level. They are used for preventive actions to avoid delivering things that are not in order. Thank you.
Thank you so much, Abeth. Let's have our last presenter, Monica Elton.
Hello viewers, I'm here to take you through quality measurements, and we shall look at it in two perspectives, the producers and consumer. And here we are with the quality measurements. One, it's defect measures. Under this, we have defects per unit, and that's DPU. Another one is defects per unit million opportunities. And this measures how many defects occur per million possible defect opportunities. And it is widely used in Six Sigma quality management. And it has a formula for computation, which is number of defects divided by the total opportunities times 1 million, because it covers million opportunities. Then lower DPMO indicates quality performance, and then high DPMO indicates poor or fair quality performance. Another one, we have statistical measures. Under this, we have the mean, which is the average, which is a summation of the number of units divided by total number of the exact units of observation. And it represents the central value of a data set. Another one is control charts. Here we have X-bar charts, and these ones deal with average, and it monitors changes in the process of the average. We have the R charts, and they monitor variation within samples by measuring the range. And range is basically the difference between units. We have the P chart, which is a proportion defective measure. It is used for proportion of defective items in a sample. Another measure is consumer-based measures. Here, quality is measured from customer's perspective, which means we shall measure it in a relation to the customers. So the measures include the customer satisfaction surveys. Here, a researcher goes out in the field and headhunts for the customers who have benefited or who have used the products, and then he or she ascertains how the product is in terms of utilization. Another one under the consumer-based measures is complaint rates. The researcher goes out and then seeks the complaints about the products. And also another way they can measure under the customer-based measures is the return rates. Here, they look at the level of returns in a way that when a customer buys a product, there is a possibility that he or she brings it back. That's a return. So the more the rates, it really indicates how the quality of the product is. And then another section we shall go through is process capability. Process capability measures how well a process produces output within specification limits. So by definition, process capability refers to the ability of a manufacturing or service process to produce output that consistently meets predefined specification limits set by the customers and engineering standards. Here, capability means how is a product able to meet quality, and how do the customers feel like this is a satisfactory product. So it answers questions like, can the process consistently meet customer requirements? And the key indices are the CP, which is the process capability index. It measures the potential capability of a product. And for computation purposes, it is abbreviated as CP with a formula of USL minus LSL out of 6 sigma, whereby USL is upper specification limit and LSL is the lower specification limit. And the higher CP means better capability of a product, and a lower CP means a poor or fair capability basing on the test criteria. And then another key index is CPK, which is the process capability index adjusted. It measures actual performance considering process centering. CPK measures the actual capability of the process. So here, if the CPK is greater or equal to 1.3, it means it's a good process. But if the CPK is less than 1, it means the process needs improvement. Thank you so much.
Thank you so much, Elton. This is all we had as Group 1 students.